Friends, today everyone seems to be on the fast track. No one is prepared to wait for anything. While we waited for more than a year for the delivery of a car, in the 90s, today we get a car from the showroom. We can just drive it home. Massive automation, AI like technologies, they enable our fast track living. Even as the raw materials deplete much faster, leaving a larger carbon footprint. The downside, all that comes at a price. Are we willing to pay that price for the development that we are seeking? The future landscape of manufacturing is dark factories. And dark factories are highly automated, efficient manufacturing systems designed to operate 24/7 with minimal oversight. There is absence of human activity with lights off, often turned down to reduce energy consumption. In future, factories will operate with minimal human intervention. Primarily relying on massive automation, robotics, AI for most of the operations. But yes, it can cause loss of jobs. Dark factory hardly has people in it. So friends, today my subject for you is something on dark factories and how we conduct our lives in this digital transformation age. Historically, factories were hubs of human labor, with workers responsible for managing the machinery, assembling products, and ensuring the quality of goods. However, Industry 4.0 has made it possible to automate almost every aspect of production. Not only the technologies allow for systems that can not only operate autonomously, but can also in real time adjust to variations in production requirements and changing conditions. A peek then into the dark factory life is called for. That's what I'll do this Saturday. While automated machines and robots perform a variety of tasks with high precision and speed, AI plays a vital role in optimizing production lines, making real-time adjustments based on data analytics. While robots help in repetitive tasks in automating them, such as assembling, components, packaging, or moving materials from one station to the other within the factory, AI predicts maintenance needs. It identifies potential failures as well before they happen, and even adapt to changes in production schedules without human intervention. Now, this is achieved through a host of IoT sensors, Internet of Things sensors, that monitor machinery and processes throughout the factory and manage everything from inventory control to machinery performance. By gathering data from various points in the factory, manufacturers continuously optimize production efficiency. Besides robots, autonomous vehicles, and the other AVGs are also used to transport materials and finished goods between production areas or production sites, reducing the need for human forklift operators or other transport personnel seen in traditional manufacturing setups. Thus, traditional manufacturing is rendered redundant, right? With most of automation taking over the functions. Further, machine learning algorithms allow systems to learn from past data and improve the efficiency and quality of production, rendering an entire area of traditional quality control also redundant. Over time, these systems become better at predicting failures adjusting to fluctuations in demand, and fine-tuning the entire production process, thus rendering a traditional maintenance system also redundant. Of course, dark factories offer several significant advantages for manufacturers, such as increased efficiency, cost reduction, improved quality, almost zero overheads, enhanced flexibility, and reduced labor dependency. Machines do not need breaks or sleep, leading to higher throughput and reduced downtime. They can't form unions and demand bonuses, reducing the labor cost. They often perform tasks much faster and more accurately than humans, lowering further the production costs. While the initial setup of a dark factory is expensive, the long-term savings are phenomenal, substantial. The automated systems are designed to operate with high precision, resulting in fewer defects and higher quality products. The consistency of robotic manufacturing ensures, that each product meets the required standards without the variation that can arise from human error. This eliminates rejection and reworking of parts. Flexible manufacturing systems, or FMS, in dark factories quickly adjust to changes in demand to product specifications which may change online without the need for extensive reconfiguration. This gives greater flexibility to meet market needs. Should we as a nation adopt dark factories culture? The answer is yes, since otherwise we would be neither competitive nor acceptable in global markets. Be that as it may, the flip side is a price we will need to pay. There is a potential job loss scenario. As robots and AI replace human workers, entire segments of workforce will find themselves displaced, exacerbating income inequality, highlighting income inequality, and growing unemployment rates. Now, the transition is fully automated factories can be very disastrous on labor and their livelihoods. So, what is required? We need training, retraining, skilling, upskilling, so that people do not become redundant. On the technology front, dark factories are vulnerable to cyber attacks. Since they rely on interconnected technologies and the internet, hackers could potentially infiltrate factory networks, disrupt production processes, and steal sensitive data as well. Now, the risks associated with cybersecurity are particularly concerning when these factories are responsible for producing critical infrastructure components or sensitive technologies like that are needed for the defense. While entry-level jobs requiring low-end skills will dry up, managing and maintaining the highly complex systems will require specialized knowledge and high-end skills. That's where reskilling and upskilling matter. Some ethical concerns to arise, regarding the extent to which humans should relinquish control over production processes of machines, especially in industries that require high levels of customization or judgment. What can be done? Industries such as automotive manufacturing, electronics production, and consumer goods are already seeing increased levels of automation. And this trend is expected to rise. The shift towards fully automated automation will require significant changes in education and workforce training. Are our universities game to provide these skills? Besides, governments, businesses, and communities will need to work together to address the social and economic implications of this shift, ensuring that displaced workers are retrained for new roles and that the benefits of automation are distributed equitably. It will also be essential to balance efficiency gains with the need for human labor and ethical considerations. Now, while there is an increased productivity and lowered costs, the impact on employment and the economy must be carefully managed to ensure a sustainable and inclusive future for all. Now, that's the subject for this Saturday. Dark factories and what they can do for us and what we need to do in order to be a step ahead of them. Very simple. Skill, reskill, upskill. With that, friends, I end today's Saturday's episode with a promise to be back the next Saturday. Until then, thank you. Dhanyawad and namaskar.